All right, so last week we were looking at static electricity. So we'll go through kind of a quick review of what we saw last week and then get into some new material. So we found out that when materials are rubbed together, electrons can transfer from one material to the other. Remember that if you have an atom of something, that atom has protons, neutrons clumped in the middle, and then the electrons were in the shells on the outside. So the electrons are not held as tightly, so it's pretty easy to pull them off, right? Those negative electrons, you can pull them off and move them onto a different atom, onto a new material. And we did that with the simulation the other day. We took that balloon, rubbed it on the wool sweater, and we noticed that the electrons came off of the wool atoms and they moved on to the rubber atoms of the balloon. And we ended up building up this negative charge with extra electrons on the balloon and a positive charge where we were missing electrons on the sweater. And when you get this buildup of charges, where you have more electrons than you would normally have, you have extra electrons, or you're missing electrons, we call it a static charge. And static meant that it was stationary. It stayed on the object that you had it on. And it'll just sit there until you maybe touch that against another object or you touch it to the ground or something like that. All right. And we also looked at, how do you tell which one is going to become negative or positive? And we found out that you can use that electrostatic series, that list. Right? So we looked up rubber, we looked up wool, and we noticed that rubber was having a stronger hold on electrons, so it became the negative. The wool had a weaker hold on electrons, it became positive. All right, so the new thing for today's lesson is we're going to talk about two different types of materials. So we can put materials into two different categories. We call them either insulators or conductors. All right, first one are insulators. So insulators are materials that electrons cannot move through. So the electrons are on that material and they just stay there. They can't move through it. They don't even spread out on it. They'll just stay wherever they were formed. Examples of insulators are rubber, like our balloon, glass, wood. If you think about trying to make an electric circuit, you couldn't use any of these things in an electric circuit. Right? If you tried to plug a light bulb into a battery and all you had was a rubber cable or a glass cable or a wood cable, it wouldn't work. And that's because the electrons can't move through those things. They would just stay in the battery. They couldn't move to the other side of the battery. So in this case, our balloon is an insulator. So when you rub it on the sweater, it builds up these extra electrons and they don't even spread out on the balloon. They actually just stay on that side of the balloon and they don't move anywhere because they're not able to move through plastic. And that's because or the rubber, sorry, that's because the rubber balloon is an insulator. Similarly, if we rubbed the wool onto a glass rod, the electrons would only stay wherever you rubbed the glass rod. They wouldn't move anywhere else. All right, the next category are called conductors. This is a material that allows electrons to easily flow through it. That's what we call a conductor. Examples of conductors are copper, gold, seawater, so salt water. So if you put electrons on these things, they can easily move through them. And if you have something like a battery that's pushing the electrons, they can flow right through these materials. If you took a ball of copper and you tried to build up a charge on it, you could build up a static charge on it, but it would just spread out all around it. So conductors are used when you want the electrons to flow. Okay, where are some places where you want electrons to move? Well, anytime you have a circuit, anytime you're using electricity, like the circuit that runs the lights in your house, or the circuit that's running your stove, or your TV, or your phone. So you want electrons to flow, maybe in the power lines that bring power to your house, in the electronics that you're using, or the appliances that you're using. So in all of those cases, you're going to use a conductor because the electrons can just move right through it. So the wires that are in your house, those are all made out of copper. The circuit board that's in your phone, it also has little copper wires in it, and it has little traces that are made of copper that the electrons can flow down. And it even has some sections that are made out of gold, because gold allows electrons to flow even easier than copper does. So in the really important parts of the circuit board, they'll use small amounts of gold. All right, so we're going to go through a little bit of an activity here, and we're going to plug in these different materials and see if they're conductors or insulators. And I got that open over here. All right, so what we have down here is we have a battery, and if you connect the battery up, we have a positive and negative end of this battery here. It goes through a light bulb, and if we were to connect these together, that would complete our circuit. The battery will push the electrons. It will allow them to flow through the wire and through the light, and then the light will turn on. In this case, there's a big gap. All right, so the light is not on because there's no pathway for the electrons to flow from one end of the battery to the other. So the light is not turned on. In this case, we would say that air is actually an insulator. Electrons do not just normally flow through air. All right, what we're going to do is we're going to go through and take the different materials and throw them in here between the two wires and see if the electrons are able to flow through it or not. If they're able to flow through it, then it's a conductor, and you'll see the light bulb turn on because the electrons will start to move. If the material is an insulator, the electrons won't be able to go through it, so there will not be any electrons flowing. They'll stop here and they can't go through it, and the light bulb will not turn on. All right, so let's test out the different materials. First one was the alloy, the metal. So we have like a metal wrench here. We'll put that into our circuit, and okay, the light turns on. Electrons are flowing from one end of the battery. They go through this wrench, this alloy wrench, metal wrench, through the light bulb, and it turns on. That tells me that the alloy, the metal alloy, is a conductor. Okay, so we'll put conductor for the alloy. All right. Next one, water. This is pure water with nothing in it. We call that distilled water. Plug that into our circuit, and nothing happens. So if you have pure distilled water, this is only H2O molecules, there's nothing else dissolved in the water, that's actually an insulator. I for insulator. Electrons cannot move through it. Now you might be thinking, hold on though, I know that it's dangerous to have things like hair dryers around a bathtub, right? And that's because the water that's coming out of your tap is not pure distilled water. It actually has things that are dissolved in it. It might have some tiny amounts of metals. It might have chlorine. It might have a number of different ions that are dissolved in it. So the water out of your tap, it actually acts a lot more like salt water. And in this case, salt water is a conductor. So electrons can move through salt water. Salt water is a conductor. And that's why you want to keep things like your hair dryer away from your bathtub, because the water that comes out of your taps is a conductor, and if you dropped it in, electrons could move through the water. All right, next one, copper. Right, you can kind of take a guess here before I put it in. Electrons flow, copper is a conductor, and in fact, these wires here, they're actually made of copper already. What they did is they put a little plastic sleeve on them just to protect them so they don't get damaged or they don't rust away. But these wires are already made out of copper. Copper is a conductor. All of the power lines out there, they're all made out of copper. The wires that are running through your walls that go to your lights and your light switches, those are all made out of copper too. Well, copper is a relatively cheap conductor, relatively cheap metal. Next one, glass. You can take a guess before I put it in there. Insulator. Electrons do not flow through it. Glass is an insulator. Next one, a wood pencil. Take a guess here. Nope, doesn't flow through it. Wood is an insulator. Next one, graphite. So you take just, if you think about a clicky pencil, if you take out one piece of graphite there, stick that in, take a guess, and the light turns on. Okay, graphite is a conductor. If you think about the demo that I did when I split apart the water, right, we connected that battery up and we put the two different ends of the wires into the water and we split it apart and it made hydrogen and oxygen gas. Right? We captured the hydrogen gas in the test tube and then we lit it on fire. It went pop. In that case, I actually attached something to the end of each wire and I attached a piece of graphite. And that's what I put into the water. And the graphite, well, the graphite allowed the electrons to move down it. I used a type of salt water, which allowed the electrons to move through it. So we actually saw both the salt water and the graphite in that demo, and both of those were conductors, which allowed the electrons to flow from one end of the battery to the next. Aluminum. So I take my metal, my aluminum ruler, I stick that in, and yes, it is a conductor. Electrons can flow through aluminum. Last one, plastic. Now I take my plastic ruler, I put that one in, and nothing happens. It's an insulator. All right, so generally it's the metals, right? If you think about your periodic table, the things on the left, your metals, those are your conductors, right? Alloy metal, right? Copper, iron, aluminum, gold. And other things like glass, wood, plastic, those are your insulators. So if you're trying to build up static charges, generally you'll use insulators, things like glass rods, plastic rod, ebonite rod, a rubber balloon. And those are the things that show up on your electrostatic series list. But if you're trying to make a circuit, right, if you're trying to make something that you can turn a light on or turn your stove on, in that case you'll be using conductors.